Alright, welcome back guys. Back here doing the second part of this turtle tutorial. Now the first part I taught you how to make the robot follow an individual path, like this one here, so you can just now walk around that like that. So the second part we're actually going to teach them how to make a glass tunnel. Now, I'm just going to specify the tunnel first off. How it's going to work is, it's going to be very simple. Essentially it's just going to be 3 glass bits high, 1, 2, 3, and then there's just going to be a little one in the center there that's also going to be a piece of glass. And he's just going to move along, placing that wherever he goes, including around these circles here to make sure the whole thing is sealed off very nicely. Just like that. Every 10 steps as well, I want to make sure there's a piece of glowstone, so that way the tunnel's going to be lit, and behind him at each step there should also be placed a bit of minecart track behind him as well, so that way we have something that they can follow behind as well. That's going to be the whole part of this particular part of the tutorial. Sounds pretty simple in practice, in concept rather, and in a very basic thing like just straightforward, it would be very, very easy to do, but in this situation here where we have variable altitude and turning around corners and things, it's much more complicated. So this will take a little bit of work and quite a bit of effort to think about, and I do warn you ahead of time, this will be a long tutorial, so just bear that in mind. So if you haven't already got the world file, download it. Make sure you've done the first part of this tutorial. You'll need the code that you've done up until now to do the second part. So if you've done all that, then fantastic. Let's get started. Now, make sure you're using a mining turtle here. We'll need to be doing some digging for this one as well. Just bear that in mind. Now, what we're going to do is we're going to start setting up our turtle here particularly. So we have our cobblestone here that we're going to be using again for our pathing. Let's put that in the 9th slot this time, so that way it's nice and far away from the rest of our building. And the rest of it's going to be glass, this railroad track, and the glowstone. Now you can see here, I've chosen a large amount of glass because you can see for every piece of track that we place, and every 10 times we place a bit of glowstone, we've been placing 7 pieces of glass. That's going to be the most commonly depleted. It's what we're going to call the, what you call, I suppose, the limiting reagent of the situation. So we're just going to place as much glass as we can. In fact, because we're going to be testing it fairly shortly, I think this will do for now. We'll just go with the standard 64 by 64 bits, and let's start thinking about how this is going to be working. So we'll put the rail track, let's make this consistent, so we'll put the rail track in slot number 8, the glowstone rather, in slot number 7. That will do for now. So slots 1 all the way through 6 can be made of glass too. Alright, so edit tunnel. Let's get started. Now the very first thing we're going to have to do, so what I will do here is I'm just going to do something like this. And then just up here, we're just going to have something like so that way we have it all nice and separated. That's just a good idea to have it up there as well too. Now, that we've got this going, what I'm going to do first off is I'm going to have to build a brand new method. Now you can see here that we have lots of glass here, but it's not just good enough to be able to select an individual slot here and then just say, alright, we've got this piece, so let's just place that, because there might be something in the other individual slots. So what we're going to have to do is create a new method that's going to allow us to select from an individual range between 1 and 6 like this. So how do we do that? We're going to make a new function like this. So we're going to go function, no, misspelt, function select in range, and we're going to have a range of first, last, and also a count, and that's how many items we need to place. I'll explain why we need that a little bit later on down the track, but for now, let's just follow as I go. So, essentially, it's going to be moving between the first and last and check and see whether or not there's space, whether or not there's something there that we can actually place directly. So we're going to have 1, 2, 3, 4, 5, 6 things. So here's what we're going to do. It's going to go for I is equal to first, last, just a simple for loop, do, we're just going to have that there, and in our for loop I want to do this. So I want to see, first off, remember when I was looking at the turtle slot function beforehand, there's a get item count method. If that get item count method is high enough as the number of items we actually individually require for our range, then we know that there's enough there. So what we're going to do is we're going to go if turtle dots get item count, I, of course, the item count is going to be the index we're looking at here, which is in this case I. Now if that's going to be greater than or equal to the count that we have, then we know that we have enough items. In that case, we can just do this, turtle.select I, the one that's been selected, and then we can just return true. Then we can just end that there, and then at the very end here, we can just return false. Say, sorry, couldn't find one, which is okay. Now, this, as you can see here, is going to work okay. This will be able to work here, but having said that, the main issue I'm a little bit worried about here is think about in a situation where we're digging. So suppose you're like digging through a wall and placing and digging and placing, digging and placing. You might get to a situation where if you're selecting from range, you might be able to place something, but when you dig, it means that when this is deleted, it means that the space will actually be filled up with a bit of dirt or something, and that might be used in place of something you actually want to. It means that you can get stuff inside your inventory you don't want. That's an issue that happens when turtles are digging. So as a consequence, you kind of want to leave at least one piece of the old material in there that can't be accessed no matter what. So what I'm actually going to do is I'm going to actually make this greater than count rather than greater than equal. So that way there's always one piece left over, and even if there's one piece there, it means it can't be used, can't be touched. In that instance there, then we know that we're not getting anything excess in there as well. So that's perfect. That's exactly what we want there. So that will solve us that particular problem. Anyway, now that we can select in range, we actually start using that in our regular thing here. So we're going to build a new method here. So we've got to select in range. We're actually going to build a brand new one here that's going to allow us to build and place things. So we're going to create a new function. It's going to be called function build section, like this. Alright, Now this is where things are going to get sort of interesting after that sort of bit of trickiness there. So, first off, we have to make sure we're selecting the right item. So in this case here, it's going to be between 1 and 6. So we're going to use that thing here, select in range, 1, 6, first and last. How many items we need? We're going to need a total of 6 items there, and that'll handle that nicely. Sorry, 7 rather. 7 other items. So think about it. So it's going to be 1, 2, 3, 4, 5, 6, 7. So if we just build that in glass ourselves, 1, 2, 3, and then this wouldn't be built by the turtle, but we'll have a piece like that, then 4, and then we have 5, 6, 7. Why I've made it 3 high as opposed to 2 high is because when those big altitude drops appear like this, you might get a situation where you have something like this here, and then, if this is only 2 high, it means that you might not be able to fit a minecart there, specifically, because that might be too low. And then, yeah, you wouldn't be able to fit through. So that's not going to be any good. So in that case, we're going to make them 3 high, just make sure we have enough space for our minecarts. Sorry, just need to make sure that's all nice and clear. So now with that done, we can now start placing. So what we're going to do here, and then again, this is going to read like fairly messy code, but there's no real way around, so we're going to go like this. Now I did say I warn against this sort of code, and I do, but there's just no way around it in this case. You just need to have that explicitly written out, just like that. So, let's just follow to make sure you see what you've done here. So we're going to turn left, we're going to place the first piece, then up, place the second piece, place the third piece, we're going to turn right. So we've just gone, turn left, place this one, gone up, place this one, place this one, we've gone up, then we've placed it directly above us, and we've turned right again. As you can sort of see here, we've turned, placed up, then we've turned right a second time, then we've placed, then we've gone down, we've placed, we've gone down, we've placed for the final time. So we've placed all 7 of the pieces that we need to. So that's now been set. So now what we can do with this section here, pathing, wherever we've done this follow path thing here, before we even check for pathing, let's just place a section. We're going to go build section like that. I think it was called build section. Again, just make sure you check this stuff. Excellent, good. Alright, that should do the trick. And then, assuming that we've made the right-hand turn, which we haven't, this is always, again, remember what I mentioned about always making sure that you return the turtle to its old state? This is exactly why, because otherwise we'd end up facing the wrong direction. So that'll work nicely. Make sure you've done that. Now, I reckon that should do the trick. So, let's see what happens. Turning left, now, up, right, right, and fantastic. Okay, so he's now placing that tunnel exactly how we want him to. Aha! But I made a mistake. And the main issue here, as you can see, the reason he's got that wrong is because, we're going to edit tunnel again, and this is okay, it means in the old bit of code, was rather, see, what's gone wrong there? Ah, okay, disk 2, he's getting too confused, see, tunnel, edit tunnel. Alright, so, the main issue there is the thing is that beforehand we've been checking with our compare function here, and this is always being done in, where are we? Our follow path function, here we are, and we're using our compare here, but unfortunately we're always looking at the wrong item here, so we're going to have to use that select from range again to make sure we're selecting the 9th box. However, because the 9th box is never moving or changing, we can just change exactly to turtle.select 9. So in that instance, wherever we've done turtle.compare down, make sure just before that we've added a turtle.select 9. Just like that, and we'll do that to all 3 instances where that comparison occurs. Is that necessary? I don't know that it is. It might be, just to play it safe. It's just, again, always a matter of safety, being careful, not letting anything go onto wall, because we might have to do some changing to stuff later. So I'm going to turtle.select 9 like that. That's a good idea, just in case. Alright, and that ought to do the tricks. Now, let's give him a try and see what happens. So, he'll now place that bit of wall. Now he's checking the 9th piece, that's okay. So now you can see he's building that really quite nicely. Now we'll see here, we'll be fine once we reach, for the first couple of sections, that's going to be okay. We're going to have issues in a couple of minutes when we reach this point here. Okay, so he's checked this will be okay. So this part's very easy, and you can see here, this is very basic. It's getting it working correctly, that's where things get a bit tricky. Now you can see here, unfortunately, look, we've built this big glass wall in the way. This is no good. He actually can't get through that, even though there's a path there in the way. Now, we know the fact that this glass wall, this is being erected by him, and we know that glass wall is actually safe to move back. So we can go back 4. I think it was 4 spaces he moved forwards. That's right. Oops. Sorry, wrong one. So what actually we want to do is now, whenever he checks to make a left or a right turn, excuse me, whenever he makes a left or right turn, we can always check to see whether or not he's safe enough to destroy through those individual walls there, to the left or to the right. Because if he is, then he should just go ahead and barrel right through them. So we'll use a function called destroy wall, something like that, to be able to do that. So let's actually just go into our code now. Now it's just old disk again, so just going to edit tunnel again. Whoops, my mistake. Okay, now that we've done this, where we've done our individual path, we're going to have to make changes to the way the path is working. Whenever we're doing our check here for our total lot up, we have to make sure we're comparing it with the right material. So we have to allow a situation where we can destroy the old bit of material for us to work directly. So what we're going to do is we're just going to go like this. We're actually going to go here. Select from range, I think it was that, 161. We just need the one piece, of course, just to make sure that we can use the comparison. Just checking to make sure that's the same one. Select in range rather than select from range. Again, always check these things. It's a really good idea to use this in a different editor as well if you have that problem. Now, if turtle.compare, then we know that we've got a glass wall, and that glass wall should not be there. So in that case, we're going to have to knock it down. So this is what we'll do. Then... And now, if we know there's a glass wall in the way, then we know we can move forward and it will be successful. We know that for a fact. We can just go just like this, just turtle.dig, like that, very simple, and just go turtle.forward. And then we can just go turtle.dig up, turtle.up, turtle.dig up, turtle down. So that way he's cleared out the wall as it existed beforehand. So he's going to dig right through that wall, and then that forward, as we can see there, it's now been successful, so now we just return true. You could make that a separate function. We're only using the one, so we should be okay. Now, you could use it a second time to check the second time he tries to move forward, so whether or not this has actually succeeded here. I'm not going to do that, and the reason for that is because if that situation has occurred where there's a glass wall up somewhere like, hold on, here, it means that the only way that could have occurred is if it's on the left or the right hand side, like here. And the thing is, this shouldn't be a legal track. Why? If you just check here with your railway, not legal. You can see a train actually isn't able to move that directly. So it's not a good idea to actually allow that. Okay, so I'm just going to remove that bit there. Just leave that nice and clear. That's actually the safer way to go there. So in that instance there, I'm prepared to say, listen, you don't need that a second time, just the once will be fine. So that's okay. However, in the situation that he's gone through that wall, and then he's realized, hold on a second, there's not a path there, then you've just destroyed a bit of wall that you wanted beforehand. So we actually need a function to seal that back up again, to say, you know, whoops, bashful sort of thing. So we'll do that. So I'm going to create a brand new function at the top here as well. It's going to be called turtle.sealWall. There. Function seal wall, like that. So in this instance here, we have to seal that wall back up again. So in this case, we're going to assume that he's moved back to his old position. So we've just bombed through like this, bombed through there. Then we've gone, oops, no good. So now the turtle has moved back to his old position here. Now he should just, before he goes ahead and tries this new wall to check to see whether that one's okay, he's just going to turn around, build up the old one again, and then just turn back where he was beforehand. So again, all keeping the same state. So now what we're going to do is we're going to go turtle.turn left. Again, this is not going to be very hard. There we go, and then just going to go turtle dot. Now we have to select from range again, so we're just going to do that now. In range, rather. 1, 6, and he's 3 pieces this time. Turtle dot place, that's going to be great. Dot up. No real way around that sort of code. Unfortunately, it doesn't look very great, but unfortunately this is the way that it works, because unfortunately there's no fast way to do this. You could loop this, but it's just not worth the effort, so again, it's fine as this. So that'll just now replace the old wall as he destroyed it. So, essentially, let's go back to our code and see how that's going to be working. So we're going to be selecting from this individual range here, checking each individual piece, so we'll see it works. Now, in the instance, let's go back down to our, it's going to be in our pathing function this time, so with our following path here, in the event that he's moved forward, we're going to move him forward here. At this point, this is where we're going to want to seal that wall. So what we're going to do is, at this point, assuming that he destroyed the wall, and we don't know that for a fact, but we can sort of suggest that that's a possibility. So we're actually going to call seal wall here. just in case that he's destroyed that. And we can usually assume that's going to be the case because it's unlikely he won't have otherwise. So now he has to seal that wall, then he can start doing his turn left here. It's the same thing here, and you've done your fort here again. Now before he goes, because he's now destroyed the left wall, we're going to seal that wall too. And that'll work nicely. Alright, that's looking pretty good. Now, with that working nicely as well, we have to make sure that move forward is being called, our build section is being called, and our seal wall is being working too. So that's all looking pretty nice. Alright, I reckon that might be enough. Oh no, we're going to need to call seal wall again at the very end here to say this has failed too. Do our turn left here, a seal wall here, so we'll just call that here too. Seal wall. So that way, every wall that he destroys, which is quite possible, granted the fact that there might be glass in the way, that's where we can reseal those again. So that's been done. Now we should be able to get it to work. So we're going to call tunnel and see what happens. Alright, so let's see how he goes. So his movement's looking okay. Let's just make sure that keeps up. We can just destroy a bit of stuff here if you want to test him again. Doesn't really matter. Might be good to just keep him well stocked with glass too, if you're worried about that, which I sort of am. Okay, he's going to place that up again. Now, he's going to try moving forward here. That's failed. He's just going to say... Now, he's sealing that wall that was there beforehand, so now he's actually done the seal there correctly. He's going to destroy his way through this wall, which he checked to make sure it's correct. And now we know the path is working correct, because now he's going through there as well. So you can see here, he's actually gone ahead and he's built a new section of wall based on the placing of an old one. Let's make sure that he's doing this okay. So let's just keep watching him, see what happens. So now... Okay, so that's working nicely too. He's going to go through here. Alright, good. Now, this is where the path's going to fail again. Let's see how he works. So he's going to turn around. He's going to seal up that wall. So this is working fantastically. This is exactly what we want. You can see he's actually building an internal tunnel. He can't pass through there. So now he's going to try and seal that up, which is no point, of course. He's now going to dig his way through the old wall. This is really looking good. Look at this. So you can actually see here, follow him along. Yeah, he's actually building this tunnel, step by step. Now, how does he handle altitude? Let's see how this works. And we have handled this. Let's just make sure that it's working correctly. Stepping up. Beautiful. Really good. That's exactly what we're after. So now we can handle that nicely too. This is looking great. This is exactly what we're after here. So there we go. Alright. Listen, tell you what. We might quit while we're ahead at this point. You can see this is all looking really good. Let's start worrying about some other functions. So, good work, Mr. Turtle. I'm verily impressed with that progress. So, we'll move the whole thing forward because this is going really nicely. We'll just bring this up. Now we'll just move up to over, I don't know, here-ish is probably fine. Place our turtle down again. Let's just fill them up. So this time, now we're going to start handling things like glowstone and railways. So we're going to put that there, give some more glass again. We're going to need this as well beforehand. 2. Alright, and the last one we need is that bit of stone. Don't forget that bit of stone. Absolutely pivotal that he has that bit of stone. Just grab a new disk drive. This is going well. This is good. This is what we're after. Okay, so now we're back on track. So, with this bit of things working here nicely, now it's time to start thinking about placing that glowstone. Now, what I would recommend is that every 10 spaces he should place glowstone instead of placing glass. That way we have a bit of space there. But how do we know when 10 spaces move? We have to keep a count for it. So we're going to go light count is equal to 0, and then we just have something like light limit is equal to 10. So that's something that he can stop by. And it's good to have this as a parameter rather than having it as a fixed value. That way you don't have to sort of worry about changing it too much in the detail of things. So, in our building section, wherever he does his building, and this is this thing here. Here we go. Alright, now, place up. This is the thing that we want to isolate here. So we'll just grab that and open that up. So this is here where we want to change what we're using. So, what we're going to do is now going to go, essentially, if light count is equal to light limits, then we know that we've hit that special ratio, and so we're just going to go turtle.select. This time we're going to be selecting index number 7 in index 7, and we only need the one of them, which is fine, and then we're just going to go turtle.place up, and then again turtle.select. Now I have to make sure it gets back to the old one, so it's going to be 1, 6, and we're going to be selecting, we need 3 more after that point. So we've gone 3 on the side, then 1 piece of glowstone, and then 3 on the other side, and that's going to be good. And the last thing we need to do is make sure we return our light count back to 0, which is fine here as well. Good. Then we need an else case here as well, and that's going to be using the old case, and this is just going to be using the standard piece of glass, so we don't need to change anything to the state here, but we do need to make sure that we're updating our light count. So we're actually going to go light count is equal to light count plus 1. Good. Alright, that is looking about what we're after. So that should handle lighting now quite nicely. So now he should be able to move up, place a bit of light, and instead of just using his regular stuff, and that should be looking good. Now, the only thing we have to worry about left, all that's left now, is worrying about the railway. That's the last bit of this bit of code that we need to worry about tier 2. This is going to be a little bit tricky because now we have to think about placing it beforehand. So he's going to be, essentially, he'll have to move to a new section before he can place his railway. So we should be doing this at the end of each individual move forward section. So once he's moved successfully forward, then we can check to place a bit of railway. But what happens if there's a bit of block behind him, or a bit of block sort of in front of him? That's where things get a bit trickier. So now what we're going to do is we're going to build a new function. You see so many functions, and this is going to be a function, and we're going to call this place rail, I think. There we are. I'm going to do it like that. Okay, so in this case, we're now going to start thinking about placing a rail behind him. This is the idea. So he's going to, once he's finished moving forward successfully, then we know that that bit of section has been placed successfully. Now we can start thinking about placing a bit of rail behind him. Even if he's come from a corner, think about it. So if we've gone here, so we've placed that back there as well. Then he successfully turned this way. He can still place it behind him. So there's not to worry about corners. We just need to make sure he's moving behind him. So what we're going to do, this function obviously is going to be turtle.turnLeft, then turtle.turnLeft. Again, remember what I said about making sure the state is identical, making sure that's working nicely. Now, 3 situations that can happen here. First off, the space behind him, assuming this is our turtle, there could be a block in the way. In that case, he needs to move up, place the rail behind him, turn back around, and then go back down again. That's our first case. So, if turtle.detect, then, alright, so what we're going to do in this case is we're going to go turtle.up, turtle.place, make sure you selected the piece as well, so we're going to go select in range, and this is going to be 881, of course, exactly as beforehand, turtle.place, and then turtle.down, that should be fine. Now we know that the placing will work correctly, so we can just have a turtle.turnLeft, turtle.turnLeft down here, just make sure that's nice and consistent. Remember, the same as he was exactly beforehand, keeping the state exactly the same. Now, if the turtle.detect has been successful, otherwise, now there's 2 options here. Alright, so if there was nothing here beforehand, that means he can just move directly forward. So he'll need to move forward, obviously, to be able to place it, so. Or no, actually not necessarily true. Yes, necessarily true. No, he'll need to move forward. Because again, he can't detect the square here. If there's nothing there, then he can place it right beneath him. Otherwise, he needs to move backwards, then place it. That's the 2 situations here. So we'll do the next thing. Go else, and so we're going to have a turtle.forward. That's absolutely necessary. And then, if turtle.detect down, then this is where this thing gets a bit trickier. So here, if turtle.detect down, that means there's a block directly beneath him. It's on level ground. Then we have to go turtle.back, because we can move backwards here. This is now quite safe. We're making sure it's all sort of contained. Then turtle.place. Very easy. Otherwise, and this is the case that there's nothing beneath him, so that way he's gone 1 too high, and he's got a little space here. In this case, it's just turtle.place down, and then turtle.back. And then, of course, once he's done that, he'll then return to the same square, but altitude might be different. Then he can just turn left, and he'll be on the same spot again. And that's looking really good. Excellent. Now he just needs to place that rail in our code. Now, again, I want that at the very end of our follow path function here. So once this has succeeded, right before we return true, I just want to place rail. I reckon that's it. I reckon that's all there is to it. I reckon that'll do it. So once we've done that, okay, I'm just going to go tunnel. I want to see what happens. So follow him here carefully. Now, right before he's moved there, perfect. That's exactly what I want to see. Alright, that's great. Before I go any further, well, no, I think that's really sort of it. The thing that I want to sort of stress to you here beforehand as well is that the functions that are available to turtles, they're very simple. I mean, they're just, you know, place forward, place back, nothing really complicated at all. It's all very sort of simple. So the question is, how can you do anything terribly sophisticated with the turtles? I mean, the consequence, they're very basic, sort of very stupid things. All they have is just, you know, moving backwards, moving forwards. They haven't even got good sensors. So how is it that you can make them to do such sophisticated things as what we're doing here? And the thing is that with these turtles, even though their sensory arrays and their, you know, inventory is very limited, everything about the turtles has got some very severe limitations, but the potential of the turtles is only limited by the intelligence of the programmer, and that's the thing you have got to remember. You can make these devices as intelligent or as stupid as you want to. It's all about how you use the resources that are available to you and how intelligently and how cleverly you can actually make the individual things work directly as well. And now you can see he can handle all sorts of environmental features just because we've written in and we've been careful about the algorithms that we write. And that's the big thing to remember. It's just being careful about the way that you design your algorithms and thinking about how these individual items will need to work directly. The turtle can think now. It can actually understand and solve problems, and that's what makes him as effective a tool as he is in this individual device here. And you can see now that this system, although it's quite sort of specific, it can be used for all sorts of other applications as well. It can be used for intelligent devices and all sorts of things too. So, there is a bug. Lovely. Look at that. Alright, cool. I'm sorry, I was monologuing there because I just like watching how the thing works. But you can see there's a little problem there, and the problem is that he can't deal with that drop in altitude. So, again, what I was saying there about handling every individual case, that's a case that we need to be able to handle. So, we'll just grab our disk again, and let's just see if we can solve that problem too. Alright, so we'll just grab this. But you can see here, again, and I'm pretty happy with how things are looking thus far. We've done a pretty good job, I reckon. So, we're just going to place him. Let's place him there. That disk drive is going to be, we'll have to move that once we start it immediately. That's absolutely imperative. So you can see here that it's done a move. Where would that error be occurring? Let's take a look. So build section. So once we've done our individual turning function, it looks as though he's not moving down on his second detect the right amount. And that's probably because the destroy wall is leaving him in the wrong position. So we have to make sure that he's moving down in that right bit there as well. So where have we done our build set? No, it's yeah, it's going to be in our pathfinding action. So we'll just keep moving. It was move forward that we need to. Excellent here. So yeah, this turtle lot down thing here as well, if not turtle lot forward. So we have to make sure that we're moving our detect down. So this is not being included because we're returning true here too early. Pretty simple way to solve that. We can just remove this, else this, just get that a bit of space. That should do the trick. And we'll just add one more extra end function. Oops. Great, that should do it. Really, I can't think of anything else that would stop that from working, so that way we'll have that extra detect down that's being used correctly. Perfect. Cool. Alright, should be simple. That's a good thing to worry about. I'm glad that bug came up, actually. It's a nice thing for us to think about. And also, this is cheating, but I want to see a bit of light. Let's just see if that's going to work for us. Let's get that testing. Alright, so let's see if this is going to work for us now. Not working, so now he's going to seal this wall up again, which is nice. He's going to dig out this old one. Beautiful. Perfect. Great, that's what I want to see. That's it. I reckon that's all there is to worry about. There might be a few more bugs in there as well. I'm not certain. I'm just sort of, yeah, as I'm playing very much by ear here. But from what I can see, this turtle is working correctly. And there's our light. Fantastic. That's all I have to talk to you guys about today. So, sorry about the length, that's true. I know it was a very long one. And these are not the easiest things to follow at the best of times, and I talk a bit too fast. But listen, again, the point I want to make out here, and again, I say this to every video, and I can't stress this enough, especially in this individual case here, is that nothing here is that complicated. There's nothing here to worry about. There's nothing here that's too challenging, and all the core concepts are as simple as punch. It's just about using your brain and your imagination and your thoughts to think about the individual functions and pieces that work together like one giant jigsaw puzzle. It's just one big puzzle, programming, just one enormous puzzle. And using those pieces together to be able to solve a problem and make something as elegant and simple and functional as this is the reward when you solve it. So it's just about thinking. Nothing too hard, just thinking. Very simple thinking. Nothing genius, nothing challenging, it's just basic thought. Alright, I'm rambling. That'll do. Right. Thanks very much for watching. Again, this is one of the more challenging ones. Again, quite advanced difficulty, so if you have any questions, please feel free to find me an email or just leave a comment. Hope you found this useful, as always, and yeah, keep happy and stay in good health.